All right, here I am with another episode of Ions Made Simple, and I'm going to take you through this little pictogram about ions, one page at a time. And Ions Made simplified concept of a hydrogen atom is, of course, the neutron here with a electron somewhere in its cloud. Heisenberg's uncertainty principle, all that, but I'm just showing you where it is. It's there. That's the way a hydrogen atom can be depicted. It's just a simplification. Don't get too upset about it, folks. All right. So if a hydrogen atom is, just as an example, there's an example of ionization and what it causes, which is oxidation. And this is ionization on a hydrogen atom. So if a hydrogen ion atom is hit by the right amount of magnetic energy, then something occurs called ionization. And so what causes enough magnetic ionization that this process occurs? Well, it's created by, here's the question, a physical note. Where does magnetic energy come from? Where does magnetism come from? And A, the sun, B, lightning, C, a 9-volt battery and a paperclip, or 4, all of the above. So you can answer that one. The other thing I said is don't ask me where electricity comes from, but when it shows up, it's always accompanied by magnetism. It's sort of a law of the universe that you can kind of prove or disprove or talk about. But here I've sort of showed what happens if you have a battery and a little coil to generate a spark there, and you get a spark, you get a magnetic energy. And that's Helmholtz was the first one to sort of prove that. And of course, it's involved with a lot of physics that led up to that too. It's very interesting. Electricity. Everything I like to say is magnetism, or, well, to give you everything but gravity and inertia. So what other forces do you have? Well, you have strong and weak electromagnetic forces. So except for gravity and inertia, it's all electromagnetism. Everything we see is due to electromagnetism. Electricity, or rather electromagnetism, separates atom into a positive and negative charge of an ion. So into an ion. Let me explain that a little bit. When you hit this with enough magnetism to it gives you the free electron and a hydrogen ion. So I'm going to talk a little bit about that. The formula of this would look like would be H2O in water, where it would be an H positive and an E negative and a H2O. So what that means is this adding a reactive energy like magnetism can break up those hydrogen atoms to be positive or negative charged. And so I want to kind of show that as far as H2O would be concerned, because though I was talking about the E, the OH works as the E negative actually in the water equation, along with the E, depending on how much energy is given into the magnetism. But here, this show I'd like to show you is the water comes in here and it goes past 2 charged plates. It creates a magnetic field going this way and that way. Pulling it apart, it would small drawing here, but it would pull the hydrogen and the OH negative apart. So as it would go down here, and then if it was separated by a barrier, then you would get a flow of water H2O and the OH hydroxyl ion right there, and you would get, on this flow, you would get water and a hydrogen ion right there. So I wanted to show that a little bit about what happens inside a magnetic field of a flow of water that would be. And one side would be alkaline water, and one side would be acidic water. And you know, we've come to know a lot about that because these days we have something called a pH scale. So that's how water can be two things. It can be, depending on how many hydrogen ion, it can be acidic, or if it has more alkaline, if it has more OH negative ions, it can be more alkaline. So this is what defines the pH scale. You can also have completely neutral water right here, 0. But water is always going back from one to the other depending on certain aspects of what's going in there. So so that's the pH scale, and that's why it's important. The history behind this, you know, started in the 17th century with Sir Humphrey Davy and Antoine Lavoisier, where they found oxygen bubbles coming up here, and they found hydrogen bubbles coming up here. I find that to be pretty interesting as well, too. So far, that is the pH scale, ion simplified, and the pH scale. I guess I could call this little show. All right, this is Walter Wesley bringing you all the best in water science. Bye-bye.